Moving on to our third section, we're going to be talking about a little bit about walking behaviors. We're not going to get too deep into the walking behaviors. We could spend the whole hour talking specifically about walking behaviors, but I'm just going to be talking about a couple of the parameters, in particular the social parameters, because this kind of influences the pedestrian's personal bubbles, if you will. So the key parameters we're going to be looking at are the asocial isotropic, the B-social isotropic, the asocial mean, and the B-social mean. And the reason we're talking about these is because social distancing is a large topic right now, and these control the person-to-person interactions most effectively. Other parameters like tau and lambda talk about queuing and wave propagation and things like this, but this is the base level of this is the Wiedemann parameters, if you will, of the headways for pedestrians. So some tips for calibrating it is just to remember that increasing the asocial parameters, either the isotropic or the mean, increases the general distances between people. So this is the primary distance controlling factor. So increasing it or decreasing it will have a very sensitive. It has a lot of sensitivity. So small changes will go a long way. And increasing it will increase the distance between people and thus decreasing the densities. You can kind of think of these parameters as force vectors. So as you increase the value of these parameters, they will increase the magnitude of those force vectors, thus pushing people apart. And the forces are always acting, in opposite directions. B social isotropic and B social mean increase density as well to a lesser degree, but they also control shockwave clarity. So if we're talking about queuing, for example, they will have a bigger impact in single file or banding, or conflicting flows and things like that. So you'll see that reverse shockwave parameter kind of happening there. And then talking with our development team over the last few weeks about how can we model, how can we help calibrate these walking behaviors. In our experience, calibrating these walking behaviors can be a lot of trial and error. So you do a little tweak and then you see how the simulation runs. You do a little tweak and you see how a little simulation runs. However, talking with our development team, we've come up with this calibration worksheet because where you can kind of throw in some default values that you want. So here on the left side, you can enter in the desired minimum distance, in this case in meters, the average walking speed, the estimated capacity, and then your calibrated lambda and tau values, which are other walking behaviors. But by inputting these, it will output some of the suggestions for starting points for your calibration. Now, you still might need to do some refinement depending on the data that you're seeing, but these are a good starting point for your walking behaviors. That way, you don't have to do as much trial and error. And you can see that these numbers can vary quite widely, especially in the B social mean, because again, the B social parameters are a little bit less sensitive than the asocial. So you see here the asocial parameters are barely changing as we go through versus the B social. Let me pull up that worksheet real quick. Unfortunately, we have an issue with the function for the Lambert function. I updated my Excel, and the function doesn't come through as easily, so it doesn't like this Lambert function. So I'm going to fix that before uploading the file. But here, basically the Lambert function is outputting either a -1 or this calculated value here. So for these first few ones, I just inputted the calculated value here. And so we can kind of see how it's outputting the data. So we have a few different sets of data for different distances. So we have a distance of 1 meter, 1.5 meters, 2 meters. and then seeing what the different parameters are looking like as they're coming through the data set. So what we'll do is we'll provide this worksheet with the other example files so that you have something to help you with your walking behaviors. But in general, if you want to increase the distance between people or decrease the density, then you need to increase these parameters for the asocial and and the B social parameters to increase those forces between people.